This is activity 2 from lesson 1, and the title of this activity is sorting rectangles. So you're going to take a rectangle and you're going to cut it up into halves, or multiply certain dimensions by 1/2. Now in the workbook, they want you to use a sheet of paper, which is 8.5 inches by 11 inches. And rather than to do that, I did this in Docere, and I just drew the rectangle as an 8 by 16 rectangle. So the length of A is 8 units and the length of B is 16 units. Just to make the numbers a little bit easier and to make this a little bit more visual and easier to look at. Now you can choose to do it with a sheet of paper, which is going to require you to multiply, take halves of fractions, so half of 8.5 and half of 11, and then half of those halves. So you can practice multiplying by fractions and doing it with a sheet of paper. And you can use this video as a guide to what's going to happen as you do that. All right, so the first step is to take this 8 by 16, so let's call this the width is 8 and the height is 16, or the length is 8 and the height is 16. So if I divide this in half, I'm going to get a length of 8 and a height of 8. So this is going to become 8 by 8. Now notice I'm only cutting one dimension. So the length is still 8 units, but the height has been cut in half to make this 8 by 8. That's important to note. So only one dimension is getting cut in half when I do that. So then if I do that again, now I'm only cutting the height. Now I'm only cutting the length in half, and the height still remains the same. So this rectangle here now has both dimensions cut in half. The 8 becomes 1/2 of A is 4, and so the length is 4. The height is 1/2 of 16, or 8. So this rectangle, both dimensions are being multiplied by 1/2 or being cut in 2. If I do this again, now I'm going back to just one of the dimensions has been cut. So this dimension, this length down here remains the same, but now the height is cut in half. So this height right here is 1/4 of B, but this length right here is still 1/2 of A. So this is 1/4 times B, this is 1/2 times A. So now if I cut it one more time, now both dimensions have been cut in half. So this dimension, this height is 1/4 of B, and the length along this edge is 1/4 of A. So now both the length and the height have been multiplied by the same factor. So it skips over, it's every other one, every other cut, you end up cutting both dimensions. And that's seen here. So the first cut goes from this pink rectangle to this blue square. So in this one, the height has been cut in half, 1/2 of B. A is still A, it's still the same length. The next one goes to here. This is now 1/2 the length. So this is 1/2 A and 1/2 B. So notice that this rectangle, both dimensions, the length and the height, have been multiplied by the same factor, 1/2. Then it goes to here, the green one. So this gets cut in half and ends up here. And this one, from the red, only the height has been cut in half. The length still remains the same. So this is 1/2 A and 1/4 B. So notice that in this case, this is 1/2 A, 1/4 B. In this case, this is A and 1/2 B. Well, 1/4 is 1/2 of 1/2. So there's actually a relationship here. Not saying it very well, but we'll look at this in just a moment. So now if I take this one and cut the length in half right here, I'm going to end up with this orange rectangle. So now if you go back to the very beginning, the pink one, the pink rectangle has been, the length is now 1/4 A. So 4 of these lengths will line up across the top here, and 1/4 B. So 4 of these heights will line up along the height here. So this is multiplied by the same factor once again. So A goes to 1/4 A, B goes to 1/4 B. So it skips over, it's every other one. So the first cut gives you this one, the second cut gives you this, the red rectangle, which is going to be a scaled copy, and we'll talk about that in just a moment, of the first rectangle. The third cut is a scaled copy of the first cut, and the fourth cut is a scaled copy of the original. So this is 1, 2, 3, 4, 5. So 1, 3, and 5 are scaled copies of each other, and 2 and 4 are scaled copies of each other. And once again, notice that the length is being multiplied by 1/2, and the height is being multiplied by 1/2, so the same factor. So that's the definition of a scaled copy. Each length is multiplied by the same factor. And this one, they're both multiplied by 1/4. And these down here, this is 1/2 A, and this is 1/2 of 1/2 of B. So both of these lengths are multiplied by 1/2. So this is a scaled copy of this square. And actually all squares are scaled copies of each other. So now you can line them up. And if you stack them, you can, when copies are scaled, when you're multiplying the length and the height by the same factor, we were actually multiplying them by fractions and going this way. But let's talk about it by increasing the lengths. A little bit easier to talk about it that way. So if I double the double the length up here, this goes from 2 units to 4 units. And if I double the height, this goes from 4 units to 8 units. And notice you can draw a line through those diagonals and that it lines up. And if I do that again, if I double this length, this goes from 4 to 8, and this goes from 8 to 16. And again, you can draw the same line, and that's going to become meaningful in the end. So what's happening in the y direction? So the y value is 2 times the x value. So whatever I go in the x direction, the horizontal length, the vertical length is 2 times that length. So this is 2, and you multiply 2 times 2 is 4. This is 4, 2 times 4 is 8. And this is 8, 2 times 8 is 16. You can actually see that how they stack on top of each other. It's the same over here. And so you can draw a diagonal through here. And in this case, the horizontal length is equal to the vertical length. So this line is a little bit different, but it still goes through the diagonal of the scaled copies. So in this case, the horizontal length, x, is equal to the vertical length. I should say it the other way around. Y, the vertical length, is equal to the horizontal length. So y equals x. In this case, the vertical length, y, is 2 times the horizontal length. So the horizontal length is 2, the vertical length is 4. So the vertical length is 2 times. So that's the kind of conversation that we'll have in the end. But the important point is that scaling, you can line up these rectangles along the diagonal. This is going to become a very important line at the end of this unit. And this process of making this increase in the same way, scaling it up, is called a dilation. And I think that might be the next lesson. And you can think of it as reducing it by 1/2. So multiplying it by 1/2 to make it smaller, multiplying it by 1/2 to make it smaller. So the scale factor to go from here to here is actually 1/4. It's 1/2 of 1/2. Or to look at it the other way, it's the reciprocal, or we just had this, the multiplicative inverse. So you multiply this times 2, you get to here, and multiply this times 2, this rectangle times 2, each length times 2, you get to the pink rectangle. So in one step, you're increasing it by a scale factor of 4 times. So 4 times this rectangle gets you to here. And this one, the scale factor is 2. You're increasing this by 2 on each dimension. So this is 2 times this length along here, and 2 times this length along here. And notice how the lines are different. This line is more slanted than this line. So things that are going to come up throughout this unit. So this is activity 2. You can do this with a piece of paper and you'll get the same kind of picture. And hopefully this helps you visualize what's going on if you do this with a sheet of paper.